Hi, welcome back. We're going to continue our discussion with the alternating series test. So let's suppose A sub n, the summation of A sub n, converges by the alternating series test. Well, we have two more ways we can look at this. One is what's called absolutely convergent, and the other one is called conditionally convergent. Absolute convergent. So let's talk about absolutely convergent. What this means. Absolutely means it's guaranteed to always converge. And that's what this is kind of telling us right here. This will always converge if the absolute value of A sub n converges. Well, what does this mean, the absolute value? Well, if it was alternating, this is no longer alternating. So this is no longer an alternating series. And what does that mean for us? That means regardless of sign, we're absolutely convergent if we get rid of the alternating part and it still converges. We're called conditionally convergent if the original convergence, the alternating part converges, but the non-alternating part diverges. So in other words, what we're going to do here to determine if something's conditionally or absolute is we have to drop the alternating part. So let's take a look at a couple of examples. We want to determine whether the given alternating series converge or diverge. Remember, if it diverges, it's nth term. Never could diverge by alternating series. If it converges, determine whether it's absolute or conditional. So let's see here. Well, this is an alternating series right here. Negative 1 to the n over the square root of n. So I know that this is alternating. As n gets bigger, my values get smaller, my terms get smaller, and the limit as n goes to infinity would be 0. So I'm going to say the series alternates, decreases in magnitude, and the limit equals 0. Therefore, the series converges by the alternating series test. There we go. So I know that this converges. That if it alternates, converges. So that's what this means. If the series here converges. So this is saying if the series alternates, it converges. That's what this says. But part 2 says, I want to determine conditionality. And that's what we call this. What about the conditionality? What happens if we get rid of the alternating part? In other words, take the absolute value, negative 1 to the n over root n. If I get rid of the absolute value, we're going to get this. N equals 1 to infinity, 1 over the square root of n. And notice, this is a p series. P here is 1/2. This is less than 1. Therefore, this will diverge by p series. Now, let's take a look here. What is it saying? Well, if the series is alternating, it will converge. But if the series does not alternate, this will diverge. So which of the two will it be? Absolute or conditional? Well, it's going to converge only if the signs alternate. This only converges if the series alternates. Well, what does that mean for us? Therefore, this is conditionally convergent. And there's our answer. So let's look at another example down here. Again, same type of problem. This is alternating, so I'm going to write out my answer. Ready? The series alternates, decreases in magnitude, and the limit does equal 0. I can do that. I can do that in my head. The limit as n. I can do this in my head. The limit as n goes to infinity of a sub n is 0. Therefore, the series, if it alternates, converges by the alternating series test. So I know that this will converge by the alternating series test. So let's test conditionality. Well, my conditionality says I want to check just the positive. Now, I can do this real quickly. I'm just going to get rid of the negative part, and this becomes just 1. You can do 1 to the n plus 1. That's just going to be 1 over 3 to the n. Well, this is geometric. R, the magnitude of R is 1/3, which is less than 1. Therefore, this converges by the geometric series. Right here. So what is this telling us? This will converge if it's alternating, and it'll converge if it's always regardless of the sign. You might be thinking, but this is only positive. But remember, taking the absolute value, we really get plus or minus out here. We can ignore the sign. The plus or minus would really be out here. We can just ignore it because the series will converge regardless. So here, converges if it alternates and converges if it does not alternate. Therefore, this is called absolutely convergent. And there we have it. All right. For the next part, what I'm going to do here is I'm going to write down here, are tests, but in the preference in which most people choose to do them. So this is the series tests by preference. So you may want to write this down. The first one I tend to do is geometric, by recognizing something is geometric. For geometric, here's our rules. If the magnitude of R is less than 1, converges. If the magnitude of R is greater than or equal to 1, diverges. The next one is our nth term. So let's take a look at the nth term. Remember, the nth term only tests if divergent. We take the limit as n goes to infinity of a sub n, and we don't want that equal to 0, therefore this diverges. After that, again, I'm going the order which it's eased, and I can do pretty much all of these in our head. Next one, p-series. What about an integral? We'll talk about that. P-series. If p is greater than 1, convergent. P is less than 1, divergent. Remember, of course, P has to be positive. 4. The fourth one, telescoping. Now, we don't tend to see telescoping, but it is there. So this converges if finite. If everything cancels enough with a finite number, this converges. Next, after this one, we have direct comparison. We talked about this the other day. Comparison. And that just says if B sub n converges and A sub n, the original A sub n is less than B sub n, then A sub n converges. If B sub n diverges and A sub n is greater than B sub n, then A sub n diverges. 6. Then we have limit comparison. And that just says we take the limit as n goes to infinity of A sub n over B sub n, and that is finite and positive. Then the summation follows, the summation of A sub n follows the summation of B sub n. 7. alternating series. But what about the integral? Notice, we don't like the integral test that much. So there's 6 and 7. Alternating series. That's today's lesson. And that's this. If we take the limit as n goes to infinity of a sub n and it equals 0, remember, only if a sub n alternates. It's a little bit different than p series. An n term. N term is not alternating, and the n term says a sub n has to be positive, so it diverges. But if a sub n alternates equals 0, but a sub n alternates, then this converges. And the last one, you all been waiting for it, yep, the integral test. It's not the easiest one, so I always do it last. The integral test. If f of x is positive, decreasing, and continuous, then the integral of a divergent is the sum of a divergent. They follow each other. The integral of convergent follows the sum of the convergent. In other words, they're going to be the same. All right, we have 2 more. We'll talk about those later. So I hope you guys enjoyed the video. I will see you all later. Bye-bye.